So for anybody who doesn't know, here's my 280Z. I had recently been working with Megasquirt to try to raise my filter thresholds or lag factors, which thus reduces noise filtering. Generally with ECU tuning, you want as fast as you can reasonably get data that's stable and reliable so that you can respond quickly to transients. The problem there is, of course, that with any electrical system, you're going to have inherent noise in the system that has to be filtered out. So the defaults for Megasquirt generally tend to be a little bit on the conservative side to get people up and running quickly, but you know, it's a compromise. So in pushing everything up, I was realizing that I had some noise on my RPM signal before, and it only got worse, but it didn't seem like electrical noise. It seemed actually very linear with RPM, and it seemed very consistent. One of the oddities that this actually manifested in is when I use my RPM data in something like Virtual Dyno, I get really, really sporadic power curves. The power curves are kind of all over the place because my engine's constantly accelerating and decelerating from cell to cell. So if Virtual Dyno picks up a cell that's a low value, and then the next cell it picks up is a high value on the scatter range, so to speak, there's this huge bump in power. And then conversely, it could be the opposite. You can have this huge drop in power because it picks up a low RPM cell versus a high RPM cell in the graph. I'll probably attach some screenshots to kind of show what I'm talking about. I did some back of the napkin calculations today where basically I took my log window time interval and I used that to say if these two adjacent values, if the engine was actually running in between exactly, in other words, if the high value was exactly as much high as the low value was low, how many rotations did the crankshaft go through during that time window? And thus from there I can back calculate how many degrees difference there was of crankshaft rotation from one crankshaft, degrees of rotation per rotation. In other words, like how many degrees off difference per 360 degrees were each of the intervals off from each other or off from the center point. So the calculations I did came out to my really high scatter ranges up at 6,000 RPM were about 16 degrees swing, so 8 degrees from the center point. So if the RPM was exactly in the middle, the fast one had a crankshaft reading that was 8 degrees fast, and the other side would have been 8 degrees slow. So talking to people on Facebook about it, started a couple threads around the interwebs trying to find answers to see what people thought of between what's the difference between electrical noise versus mechanical noise. How can you tell the difference? If it is mechanical noise, how do you track it down? How do you filter it out? Should you filter it out? What's the best way to go about solving this? And of course, what I found is a lot of people talking about things like the RB engines, which have a timing belt, not a timing chain, because of course with those, they're metering the camshaft, and any play in the belt system introduces differentiation between what you're reading on the crank angle sensor on the camshaft versus what the crankshaft is actually doing. So it's definitely a conversation in the RB world. So what I did to try to test this was I just printed out a degree wheel, and hooked up just taped up some solder wire just to kind of give us a reference point here. Let me see if I can get this aligned. All right, so if the difference is 8 degrees at the crankshaft, then 4 degrees would explain 100% of my error. So let's see how much we actually have here. So that is just me moving the distributor shaft. There is no movement of the paper in relation to the distributor. I've got it taped down and the paper is not flexing at all. There's no binding. So I'm seeing what to my eyes looks like at least 2.5 degrees, maybe 3 degrees. Now keep in mind, this is also just static play. What also will happen when the engine's running, and this is actually a known issue with these cars to a degree, pun intended maybe, is that the distributor shaft does not stay in one spot. And it doesn't exactly, well, it's not stable. You actually have issues where as the crankshaft's moving the shaft wants to bend and move under tension. And it can actually be so violent that the oil pump can actually skip gears on the crankshaft. It's been documented from various different builds. So people know that at high RPM and high horsepower, it tends to be a problem on these motors. And at 6,000 RPM, should I really be having issues? I don't know. But if I'm seeing 2.5, maybe 3 degrees of play at my distributor here, how much flex is there in the shaft at speed? And how much is the shaft moving back and forth as the engine oscillates, as it accelerates and decelerates through each of the power stroke intervals as the crankshaft moves? It very well might be that whether or not the RPM data is picked up, you know, where it gets picked up in the crankshaft movement might change where the reading is, and thus might change where my log intervals are kind of out of whack. Now the real question is though, how does the ECU actually calculate this data? Does the ECU see this full time, all the time, real time, and thus is always able to correct for what is most likely an accurate reading? Or is there the chance that the ECU is seeing a forward movement and adjusting spark command in relation, or maybe behind in relation, and thus causing erratic spark behavior that you wouldn't see, because as far as your logging is concerned for the spark, the commanded spark hasn't changed, but the degree of which the spark happens in relation to the crankshaft has changed. I don't know. So I'm debating, I guess, putting in a crankshaft sensor, actual, you know, something like, you know, sensing off the crankshaft itself, and then seeing what difference I have. If no difference, you know, that's unfortunate. Then I've got other problems to solve. But if I do see a difference, maybe I should log both and see how much different it is. So, yeah, fun times.